Welcome to Lesson 1.3 on algebraic properties. First, let's talk about expressions. An expression is a mathematical phrase, and we have two types, a numeric expression and an algebraic expression. When we talk about a numeric expression, we're talking about a math phrase with just numbers and operations. If we're talking about an algebraic expression, it's similar. It's a math phrase, but it has numbers and variables and operations. By operations, we just mean the arithmetic operations. We can add, subtract, multiply, or divide. An example of a numeric expression would be 5 plus 2, just numbers and operations. Notice there's not an equal sign. I haven't completed that and made an equation 5 plus 2 equals 7. It's just an expression. Algebraically, an example would be 5 times x minus 4, all of that divided by 2. Now it doesn't have to be that complicated. You can use more than one operation in an expression, whether it's algebraic or numeric. Now let's look at properties. Properties allow us to set expressions equal to each other and know that they're going to stay equal to each other. So we have the commutative property of addition and multiplication. One way to think about commutative property is that order does not matter. If I'm adding two things together, a plus b, where a and b represent numbers, then that's going to be the same value as switching the order b plus a. And we can see this really easily with just numbers. So if I add 2 plus 3, we know that that sum is going to be 5. I can change the order 3 plus 2. It's still going to be 5, so that equality stays the same. When we have numeric expressions, it's easy to see, but this property can carry over to algebraic expressions, and that's why it's so important. The commutative property for multiplication works in a similar way. If I multiply two numbers together, a times b, then that is the same thing as b times a. Using a numeric example, 3 times 5 we know is 15. If we change the order, 5 times 3 is also 15. So these expressions are equal to each other. And they always will be because multiplication is commutative. The order doesn't matter with addition or multiplication. Now, it is important to note that for subtraction and division, those are not commutative property operations. Only addition and multiplication. The associative property is also only for addition and multiplication. And a way to think of associative property is that the grouping does not matter. Associative deals with grouping. So in the addition example, let's say I'm adding three numbers together, a plus b plus c. It doesn't matter if I add the a plus b first and then add the c, or if I add the b and the c together and then add the a. And you can see this with real numbers again, so let's substitute some numbers. I want to add 3 plus 4 plus 1. If I group the 3 and the 4 together and then simplify inside the parentheses, I get 7 plus 1, which is 8. If instead of adding the 3 and the 4 first, I decide to add the 4 and the 1 first, then I get a 5 inside the group. And then I'm going to add the 3 to it, and 3 plus 5 is also 8. So you can see how these expressions stayed equal to each other because of the associative property. It works just the same way with multiplication. I want to multiply three numbers together. Maybe I multiply the first two together and then multiplied by the third, or maybe I multiply the last two together and then multiply that by the first. Pause the video and work through this example with numbers to prove this associative property to yourself. Notice how you get 90 on both sides. Now you might need to use a calculator, and that's fine for 5 times 18, or you can multiply that out on your own. But that's how the associative property of multiplication works. You just change your grouping. In the next group of problems, we're going to determine if the expressions are equivalent using the commutative and associative property ideas. So if they are equivalent, then we want to state which property is used. Notice you have to write down that first problem because it wasn't included on your notes template. So I have x plus y plus 2, and I want to know, is that equal to x plus 2 plus y? And the answer to that is yes. Because the only thing that changed, we have addition all the way through on both sides, and the only thing that changed was the order of y plus 2 and 2 plus y. So because of commutative property, that is true. On the next example, we have subtraction. And remember, commutative property does not apply to subtraction. And we can verify this since everything is numbers. 8 minus 6 is 2, and 6 minus 8 is negative 2. So those are not equal to each other, and the properties do not apply. So you may think the properties don't apply on the next problem because you see that subtraction, but let's look a little more carefully at this. When we're subtracting numbers, we can rewrite that as an addition problem. So if I take the 8 and instead of subtracting 6, I add negative 6, when you have those double signs like that, then that means that it's a minus, right? So we can take the minus and rewrite it that way. And that changes it to an addition problem. And notice on the other side I have a negative 6 plus 8. So really the only thing that changed was the order. So this is a yes by the commutative property. In the next example, we have multiplication, and the only thing that changed was the grouping. And on the left side, the x and y were grouped together. On the right side, the 4 and the x were grouped together. And so those are equivalent by the associative property. The same is true on the next example, except everything is addition. So since 5 and x and 2 are all added together, we can group the x plus 2, or we can group the 5 plus x. So that change in grouping is associative property. Be careful on this last example. Notice that we do have a group, but the group does not change. The grouping is b times c on both sides of the equation. So what really changed here was the order of the terms. A plus the group is equal to the group plus a. So we change the order of addition. That means it's commutative property. Let's take a minute to see how we can use those properties to prove an expression is equal. Now, if I ask you to prove something, unless I say otherwise, then I'm giving you something that's true, and you just need to tell me step by step why it's true. So the first step is always a given, and it can come from the left side or the right side of the equation. In this case, it comes from the left side of the equation. So I want to start with the left side of the equation, which is given, and I want to end up with the right side of the equation. And I need a reason why every step is true. So if I go to the second step, I can see that there's been a change not in the group itself, but in the order of multiplication between the xy group and the z. They switch places. So this is commutative property. And you can say commutative of multiplication, but you can just write commutative and that's fine. Now in the next step, the z is still on the outside of the group, so the grouping has not changed. The grouping has to change for it to be an associative property. But inside the group, the order has changed, so now we're using commutative property again. And then in the final step, we did change the grouping. Instead of grouping yx together, we're grouping zy together, so that's an associative property. And those reasons are how you prove. Take a minute to prove this next one on your own and then come back and check your answers. Make sure you pause the video. So in the first step, we changed our grouping over addition, so that's associative property. In the second step, or the last step, we changed the order of the terms. Instead of the group plus z, we have z plus the group. That's a change in order, so that is commutative property. Next, we're going to talk about distributive property, which is a property that we use a ton, and you need to really be used to it. You need to be able to do this without mistakes. So here's what it looks like in the beginning. You have a number, we'll call it A, multiplied by a group. Remember, parentheses indicate multiplication. So we want to multiply the group B plus C by the number or the letter A. So we have to distribute this number or letter that's out front to each of the terms. We have to multiply it by each of the terms inside the group. So what that looks like is A times B and then plus A times C. Now it does not matter if A and B and C are letters or numbers or a combination of those things. When you see something out front multiplied by a group and inside the group there's addition going on, so that addition is important, then you need to use distributive property. Let's look at it with a number. Now if I had just numbers, 4 times 2 plus 3, and I'll just write this over here. Usually what I would do is I would just follow the order of operations and I would do what's inside the parentheses first. And if I do that, 2 plus 3 is 5, and then I would multiply 4 times 5 and I would get 20. So I know this is equal to 20. Let's try this with distributive property. So distributive property says I need to multiply the 4 times the 2, and then I need to add to that the 4 times the 3. And then I can simplify those numbers. 4 times 2 is 8, 4 times 3 is 12, and when I add those together I get 20, and you can see that that's what I get. Now if I have an algebraic expression like 4 times 2x plus 3, there's a letter in there. So I can't use this method because I can't simplify inside the parentheses because I don't have any like terms. So that's where the distributive property comes in handy. I can multiply the 4 times the 2x, and then I want to add to that the 4 times the 3. And if you can do that in your head and go straight to 4 times 2x is 8x, and 4 times 3 is 12, then that's fine. These are equal to each other. But take the time to write down that middle step if you need to. It's important on distributive property that if the number in front of the group is negative, that you take the negative or even the minus sign that's in front of that number with the number when you distribute it. So I'm going to multiply negative 4 times 2x, and then I'm going to add to that negative 4 times 3y. Remember, parentheses next to each other means multiplication. So negative 4 times 2x is negative 8x. And then when I multiply negative 4 times 3y, I get negative 12y. And I don't want to put plus minus. I don't want those double signs in there. So I'm just going to call that negative 8x minus 12y. And that is equivalent to my original expression. Flip your paper over and let's look at some examples that require a little more work because they have more stuff going on. We need to distribute and combine like terms. But as we're doing this, we have to remember our order of operations. The order of operations, the PEMDAS, says start with parentheses or any kind of grouping you have. But if I look at my group, I can't simplify x minus 8 anymore. So I have to go down the list. There's no exponents, so the next thing would be to multiply or divide. This 5 is multiplied by the group, so I have to distribute before I can combine like terms. Now, a mistake that a lot of people make is they say, well, let me add this 3 plus 5, which is 8, and then distribute the 8. But the reason you can't do that is because the order of operations. Addition and subtraction is the last thing that you do. So let's do distributive property on this. Bring the 3 down. Multiply 5 times x. And multiply 5 times negative 8, which makes that minus 40. Notice I'm just taking the sign with it. No negative signs. Or no double signs. So now I want to collect my like terms. Now this next step is optional, but we could use the commutative property to rearrange our terms. Instead of 3 plus 5x, I can write 5x plus 3 and then minus 40. The advantage there is that you see your like terms right next to each other, and 3 minus 40 is negative 37. So I want to simplify those numbers. Now you don't have to write that step. If you can go from here to here, and then from there to there, then that's just fine. Pause the video and work these next examples, and then come back to check your answers. Okay, we're back and time to check your answers. Couple of things I want you to pay attention to. Make sure if you didn't get the answers I got that you look through my work and understand what I did. But in this second example, or the first one that you worked, don't forget to take that negative with the 4. So there's that negative 4 times 3h, and there's that negative 4 times negative 7. And then simplify your signs as you go through.